763 Partition Labels. This Java code uses greedy approach with a last occurrence array to return a list of integers representing the size of parts after partitioning into the maximum number of parts, such that each letter appears in at most one part. Explanation 1. Pre-computation, last occurrence. We create an integer array last occurrence of size 26. Last occurrence 0 will store the last index of A, last occurrence 1 for B, and so on. We iterate through the input string S once. For each character, we update its corresponding entry in last occurrence with the current index I. After this loop, last occurrence CA holds the index of the last time the character C appears in S2. Partitioning logic, greedy approach. We initialize start to 0, the beginning of the first potential partition, and end to 0, the farthest reach of the current partition. We iterate through the string again with index I. Inside the loop, n equals math.maxEnd, last occurrence as chart IA. For the character at the current index I, we look up its last occurrence index. We update n to be the maximum of its current value and this last occurrence index. This step is crucial. It ensures that our current partition boundary, end, extends far enough to encompass all occurrences of every character encountered so far within the start to I range. If I equals end, this is the key condition. If the current index I is the end boundary, it means we've reached the earliest possible point where we can close the current partition. Why? Because every character seen from start up to I has its last occurrence at or before I. No character within this segment S start I appears later in the string. If the condition is met, we calculate the size of this partition, I start plus 1. We add this size to our partition sizes list. We update start to I plus 1 to mark the beginning of the next potential partition. 3. Return value. The function returns the partition sizes list containing the lengths of the partitions found. Why this is fast. Time complexity, oxygen mononitride, where n is the length of the string S, we iterate through the string twice, once for last occurrence, once for partitioning. Space complexity, O1 or OC, where C is the size of the character set, 26 for lowercase English letters. The last occurrence array has a fixed size regardless of the input string length. The space used by the output list depends on the number of partitions, which can be at most n in the worst case, e.g., abcdfg, but the auxiliary space used by the algorithm itself is constant. Thank you for watching. Hope you have a good day.